Hello everyone. Now we will talk in detail how does a perceptron work. We will apply the perceptron training rule to implement different types of gates. So if you have not seen my previous videos, kindly go back to the link. Kindly go back to my previous videos of deep learning playlist so that you understand each and everything in detail. So how does a perceptron work? As you can see here in the diagram, we have inputs starting from x1 to xm. We have the weights associated with inputs. We also have a value 1 and a weight w0 so that there is minimum answer to get the output. How is it done? I'll just show you. So you first have to multiply all these inputs by their corresponding weights. After multiplying them, we have to add them so that we get a sum. This sum is passed through some activation function and then we get the output. If the actual output is different from the output that we are expecting, that means there is an error. If there is an error, we have to move back and then we have to adjust these weights so that we get the correct output. Alright, so perceptron is a single layered neural network link with 4 main parameters, which is input, weight, the activation function and the sum. So the perceptron begins by multiplying all the input values with their weights, add these values to create a weighted sum, which is further applied to some activation function f to obtain the desired output, and this activation function is also known as a step function and is represented by f. So when we have this activation function, we keep on checking the output. Now this activation function is basically very important to ensure that the output is mapped between the values like 0 or 1, or it could be between -1 and 1. So take note that the weight of input indicates the strength of the node. Similarly, an input value gives the ability to shift the activation function curve up or down. So first we have to multiply all the input with their corresponding weight, and then we have to add all of them, and then we also have to add one term which is called as bias, which is added to this weighted sum to improve the model's performance. So how we add this bias? Here we have added this bias by taking w0, which is multiplied by 1. So if this sum of multiplication of input and weight is 0 and 0 plus 1 into w0, 0 plus 1 into w0, so what will we get? We will get w0 or w0. So this is the minimum value that we will always get even if this sum comes to 0. So we will get w0, which is called as bias. Alright, now step 2, we apply some activation function. This activation function with the above mentioned weighted sum gives us an output which is in binary form or continuous set of values form. So this is how we get the output. So it is sigma wi into xi plus the bias value, and after this we pass all this through an activation function, and that function is called as f. So when we pass these values through an activation function, we will get the output. So we will pass this sigma wi fi plus the bias value through the function f. Alright, so now we talk about the building and training a single layer perceptron model. So what is a single layer perceptron model? It is one of the easiest ANN types. It consists of feed forward neural network, which means whatever output is being present from one neuron, it is transferred to the next layer of neurons, which is again transferred to the next layer of neuron. So one output of one neuron gets transferred to the next layer to another neuron as an input. Then we get another output which goes on further to the next layer. Alright. And in multi-layer, there are similar many single layer perceptron models, but there are more hidden layers in multi-layer. Whereas in single layer perceptron model, what we have the single layer which is hidden layer between the input and the output layer. Alright. So for now you can understand it this way. So we can have the different types of perceptrons, and this is how it will be built. We first initialize the parameters. We first initialize the weight and the bias, and then we forward pass, which means we compute the weighted sum of inputs. We use a step function, and after that what we have to do, whatever output we get, we compare that output with the actual output. If it is not same, then we have to adjust the weights using the perceptron training rule based on errors. And then again we have to calculate sigma wi xi, and then again we check the output. If it is closer to the actual output, is when it is closer to the expected output, that means we are moving closer to the goal. And we will keep on making those changes in perceptron. Okay. So this is again the perceptron model where we are multiplying these values. We are passing this through an activation function. We get the output. If this output is not same as that of expected, that means we have an error. If we have an error, we have to adjust these weights, so that again we go through this same procedure and we get the output. Then we again compare, and our aim should be to minimize this error. Alright. So what is the perceptron function? It maps the input x, which is multiplied with the weights, and the output which we get is fx. So fx will be 1 if wi into xi plus bias is greater than or equal to 0, and fx would be 0 if it is not a positive value. So even if it is negative, it will come out to be 0, where w is the vector of real valued weights. Bias is an element that adjusts the boundary away from origin without any dependence. So bias will keep on adjusting its value without being dependent on the input. And x is the vector of input values. X means all the input values, x1, x2, so on. And m is the number of inputs in the perceptron. So what we are getting is sigma wi xi, and if this value is greater than 0, positive, we will give it an output 1. If this value is otherwise means if it is equal to 0 or it is less than 0, we will consider it as 0. So output can be represented either as 1 or 0, and it can sometimes also be represented as 1 or minus 1, depending upon which activation function we have used. So a Boolean output would be based on this w0, w1x1, w2x2, so on till wn xn. And example such as the output based on inputs such as salaried person, married, age, past credit profile, etc. It will have only two values, yes or no, or true or false. So the summation or a summation function sigma multiplies all the inputs to their weights, and then it adds them up as follows, which is w0 into 1, which is w0, plus w1 into x1, w2 into x2, so on till wn into xn. So perceptron characteristics are as follows. It is used for supervised learning and single layer binary classifier. It creates optimal weight coefficients, and then the weights are multiplied with the input features, and the decision is made by the neuron if it is fired or not. The activation function applies a step rule to check if the output of the weighing function is greater than 0. Then the linear decision boundary is drawn, enabling distinction between two linearly separable classes. So linearly separable means it is either true or false, 1 or -1. So if the sum of the input signal exceeds a certain threshold value, the output signal will be 1, otherwise it would be 0. This is something like that you can understand. So there are different types of activation functions. We have sine function, we have step function, we have sigmoid function, we have ReLU function. There are many functions also which are there, but we will talk about those functions later on. Let's start with perceptron training rule. Alright, so perceptron is a unit built by ANN. It takes the real valued vector and it inputs x1 to xn as inputs, and the outputs are output of x1 to xn, which is computed by the perceptron. So perceptron equal to perceptron equal to 1 if all the values w0, w1, z1, w1 x1, w2 x2, so on will be greater than 0. Then it will be 1. Otherwise it will be considered -1. So where each wi is a real world constant, weight, and that determines the contribution of the input xi is also the real output, perceptron output. So now we will apply the perceptron training rule in ANN here in the next video.